Objective 3 is to determine if a sequence is either arithmetic or geometric. So by the end of this objective in this video, you should be able to, if given a sequence of numbers, determine whether it's arithmetic, geometric, or neither, based on the process I'm about to show you. So I'm going to do example number 7, and then I'm going to have you try number 8 and number 9 on your own. Now, my thought process behind how to do this begins by just looking at the sequence of numbers themselves. And in this case, I'm looking at 2, 6, 18, 54, and 162. Now, a clue, it doesn't necessarily always work, but something you can consider is if the numbers are growing rapidly or quicker than normal it seems, chances are it's geometric versus arithmetic. Because again, if you remember, geometric is a common ratio, meaning to go from the next number to the next number, you multiply by a common ratio, whereas arithmetic is a common difference, meaning to go to the next number and the next number in the sequence, you add the same number. So let's, for example, number 7, I would first look at the sequence again, 2, 6, 18, 54, 162. It is growing pretty rapidly, so I'm going to lean towards the idea of this as geometric. Just for modeling's sake, I'm going to try arithmetic as well. And this is where you just try both processes to see if you can find a common difference or a common ratio. Now to find arithmetic, again, they gave you a table. You won't always have a table, but the thought process behind it is you take the second term, which is 6, and you subtract the first term from it to see what the difference is. 6 minus 2 is 4. Then you go to the third term, which is 18, and see what the difference is between the third and the second term. We saw the difference between the second and the first is 4. The difference between the second and the third, the third and the second term, 18 minus 6 is 12. So automatically I know that by subtracting or adding arithmetic doesn't work. So I know it's not arithmetic because it doesn't have a common difference. This number changed. So then let's try geometric, see if it's geometric. Same process, second term, but instead of subtraction, I'm going to divide by the first term. 6 divided by 2 is 3. All right, let's go to the third term. 18 divided by the second term, 6. 18 divided by 6 is 3. Just to check our work, let's try the fourth term, 54, divided by the third term, 18. And that is also 3. And finally, 162 divided by 54 is also 3. So in this case, this sequence is geometric because it has a common ratio, meaning 2. I'm going to write it small. 2 times 3 is 6 times 3 is 18 times 3 is 54 times 3 is 162. So to get to the next number in the sequence, you have to multiply by the common ratio of 3. So the common ratio is 3. So at this point, go ahead and pause the video and try number 8 and number 9 on your own. Alright, at this point, you should have paused the video and tried number 8 and number 9 on your own. I have shown my work, so please check your work with mine to see if it's similar to yours. And I determined that number 8 was arithmetic with a common difference of 20, and that number 9 was neither, because it had neither a common difference or a common ratio. Let me explain my thought process through that. So again, for number 8, I had to determine, did it have a common difference, or did it have a common ratio, or did it have neither? So I tried, because the numbers didn't go up as quickly, I tried common difference first. I tried to see if it was arithmetic first. So I took the second term, subtracted the first term from it. 34 minus 14 is 20. Then I moved to the third term, 54. Subtracted the second term from it again, because again you just pick one term, subtract the one before it. 54 minus 34 is 20. Then I tried 74 minus 54. 74 minus 54 is 20. And then finally 94 minus 74 is 20. So in other words, the difference between each one of these terms is 20. And you add 20 each time to get to the next term. Because I found that it was arithmetic, I didn't have to try geometric, but just to show you, 34 divided by, or there is no number 14 times the number to get to 34. It's not the same as 34 times that same number to get to 54. 34 divided by 14 is not the same as 54 divided by 34. You can check it if you want. But I found the common difference is 20. Then moving to example 9, or the third example. For arithmetic, I tried that. The second term minus the first term, 16 minus 24, is negative 8. But 36 minus 16, the third term minus the second term, is 20. So because these two numbers are not the same, I know that it's not arithmetic. So I tried geometric, seeing if there was a common multiplier in between each term in the sequence. So I tried the second, divided by the first. 16 divided by 24 reduces to 2/3. And then 36, I didn't write that, but 36 divided by 16 is 9/4. Since these two things are not the same, it isn't geometric either. So in this case, it is neither because it doesn't have either a common ratio or a common difference. If you didn't get number 8 and number 9 correct the same way that I had it, please raise your hand so I can come talk to you about it. All right, let's move on to writing a sequence. The first term of a sequence is called the initial term. We label this term a sub 1. So in order to write the sequence then, if given some information, and this helps us to think about the math between how to find specific terms within a sequence. If I have the first term in this sequence is 7, I put that there. And I have the common ratio is 2, meaning that I multiply each term in the sequence by 2 to get to the next term. So 7 times 2, so I'll put that up here. 7 times 2 is 14. So I know the next term is 14. Then 14 times 2 is 28. So 14 times 2 is 28. 28 times 2 is 56. And 56 times 2, I can finish that out. 56 times 2 is 112. So I can, the same way as I can come up with the common ratio, if given the common ratio in the first term, I can list out the sequence in order as well. And the same thing for example B, I will do this one. I'm going to have you try C and D on your own. First term is again 7, but this time the common difference, and difference is again arithmetic, meaning I'm adding to get to the next number, is 2. So 7 plus 2, and I'm adding this time, is 9. So 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 13. 13 plus 2 is 15. So this sequence begins with the first term of 7. The common difference between the two is, or the common difference between the numbers is 2. So I'm able to write out that sequence as well. Moving along, go ahead and pause the video and try C and D on your own. C is a common ratio, so you should know that you're multiplying by 5 to get to the next one. And D is a common difference, so you should know that you're adding by negative 15. Pause the video and try that. At this point, you should have paused the video to try C and D on your own. Here are my answers to this process. For C, it gave me the first term, a sub 1 is 3, so I put 3 in the first slot right here. And then it told me the common ratio is 15, so I know that I need to multiply by 5 to each of the terms to get to the next term. So 3 times 5 is 15. 15 times 5 is 75. 75 times 5 is 375. And 375 times 5 is 1875. And then finally for D, the first term they gave me was 4, so I put that here. But this time they said the difference was negative 15, so I know that it's arithmetic, and I'm adding by 15 each time. So 4 plus a negative 15, adding by negative 15. 4 plus a negative 15 is a negative 11. Negative 11 plus a negative 15 is a negative 26. Negative 26 plus a negative 15 is a negative 41, and a negative 41 plus a negative 15 is a negative 56. So go ahead and check your answers with mine. If you did not get what I got, please raise your hand so we can talk about it, because this understanding is very crucial for this module. To tell the difference between geometric and arithmetic, common ratios and common differences.